Assalamu alaikum. My name is Abdur Rahman and my roll number is 16T22. In today's lecture, we will study about the adaptive filter. So we have the few points. That is, it is a self-adjusting. It has self-adjusting characteristics. That is, its characteristics. It can change it by with respect to time, and constant weights can be used. Previously, we used constant weight, but in this form, in this filter, we can choose varying weights as our system is changing with respect to time, and it's as following applications that it can be used as telephone echo cancellation, noise cancellation, biomedical enhancement, and adaptive control. We see through an example, that is, we have our desired signal, and we, in the first case, we have our noise at this location, and with the passage of time, our noise is shifted further. So we want to calculate such a filter so that it can adapt its characteristics, so move towards where the noise is, so it can work accordingly. So work signal changing environment, as the environment changes, the signal also changes and the noise also shifts. So one type adaptive filter, what does it mean? It means that it has only one weight involved in it. We see some equations, that is, d of n is equal to s of n plus n of n, and where s of n is our, where n of n is our noise and s of n is our signal, and y of n is represented as w of n into x of n, where w of n is the weight and x of n is the other noise, and e of n is the error, that is calculated by d of n minus y of n, represented by s dash of n. We see by a block diagram of adaptive filter, that is, we have two microphones attached to it. The first one we get signal and noise, and the second one only noise is attained from it, and the signal and noise is converted to digital, that is ADC, and represented by d of n, that is, we have seen above. And similarly, the noise is also converted to digital, analog to digital converter is used, and then that is represented by x of n, and it is fed to adaptive filter as well as the LMS algorithm that we will see ahead. And the summation of both calculated by error, that is e of n, and the values, then the feedback is used, and LMS algorithm is used, and the weights are adjusted accordingly, and we see the output at the microphone, and DAC is used to convert back the digital form into analog. So here we see that how our weights are adjusted using the LMS algorithm. We have the equation mega n plus n is equal to mega n plus 0.01 of e of n into x of n, where e of n is our error and x of n is our signal. So we have a table from which we have obtained the values of e of n and x of n. So firstly, we have to guess the value, that is mega of w of 0 is equal to 0.3. We have selected a value 0.3, and we have used these values to iteratively calculate our w1, w2, w3 up to our required values. So firstly, w of 1 is calculated, that is w of 0 plus 0.01 into e raised to power e of 0 and x of 0. So we have put the values, and we got the answer. W of 1 is equal to 0.30. Similarly, w of 2 is calculated at 0.304, w3 0.354, and w of 4 0.352. Similarly, by at the end we have to converge to a point. So by using these iterations, our the final value of our weight is adjusted at the end. So moving on towards the multiple tap FIR adaptive filter, we see the equation that more than one taps are involved in it, that is y of n is equal to summation I is equal to 0 to n minus 1 w of n of I into x of n minus I. So we open this summation to get mega of n of 0 plus x of n plus omega of n of 1 plus x of n minus 1 till our desired value, that is omega n minus 1 into x of n minus n plus 1. So the next topic is Wiener filter theory and LMS. So a block diagram is represented. Similarly, same is the case here, that we have signal and noise, and noise is fed to the Wiener filter, and we have the summation of both at the end to calculate error. Error represented by e of n is equal to d of n minus omega x of n. We take the square to get d of n minus omega of x of n whole square. Open the square, we get d square n minus 2d of n omega of n into x of n plus omega square x of square of n. We get the expected value by calculating these formula. So we represent this value by j, and the whole value is represented by omega square, and our expected value of dn into x of n is represented by p, and omega e of. So we take the derivative of this equation to get dj of over d of omega is equal to, with respect to omega we have to derivate it, so we get minus 2p plus 2 of omega r. We equate it to 0 to get the slope of this equation, so we get omega is equal to r inverse onto p, where r is the representative of e into x square of n, that is autocorrelation, and p is represented by cross correlation, that is e of e expected value of d of n into x of n. The next topic is steepest descent algorithm of LMS. The formula that is used by this algorithm is omega of n plus 1 is equal to omega of n minus mu dj over d omega. The value is obtained from the previously derived equation, and similarly mu is the controlling factor, that is the greater the value of mu we have a high error, and as the value of mu is less, the error is also low. So j is equal to e square of n, and we know that that is equal to d of n minus omega of x of n whole square. So we derivate it to get the value 2 into d of n minus omega into x of n, and similarly the power is firstly written, and then the whole equation is written, the term is written as it is, and then we derivate it with respect to d of w. So we get the value 2 into d of n minus omega of into x of n and minus x of n. Okay, by multiplying it we get this values, and by taking x of n common, so we get the final value, that we know that d of n minus omega of x of n is equal to e of n. So by if we substitute it to get dj over dw is equal to minus 2 into x of n into e of n. The steps to calculate the function steepest descent algorithm is that we initialized our weight, that is omega of 0 to omega of 1 into till omega of n minus 1 desired, and we read d of n into x of n, that is y of n is equal to omega of 0 into x of n plus omega of 1 into x of n minus 1 till. So compute error by this formula, e of n is equal to d of n minus y of n, and we update the coefficient for I is equal to 0 to n minus 1, omega of 1 is equal to omega of I plus 2 into omega of e of n into x of n minus I. So by using these steps we can solve our example that I discussed in the forming lecture. So thank you.